final approach. During the final approach, it has sometimes been suggested to maintain a trajectory slightly above the glide slope. This is not a satisfactory procedure for transport aircraft for several reasons. When established in descent on the standard approach slope, as the vortex is descending, there is little risk of encountering the vortices of the previous aircraft, except possibly when reaching the area of the ground effect. However, this possibility has not led to an unsafe situation. No accident in ground effect recorded on transport aircraft with standard separations. If the aircraft is flown too high above the threshold to avoid a possible encounter, it will lead to a long landing and therefore significantly increase the risk of runway excursion. It is well known that runway excursion is already, today, the main cause of accidents, and such a technique would only increase that risk.
Larger aircraft on the same runway stay at or above its flight path, noting its touchdown point and landing beyond it. In the case of parallel runways closer than 2,500 feet, landing behind a larger aircraft requires the pilots to be aware of possible wind drift towards their runway. Stay at or above the larger aircraft's flight path and note its touchdown. If you are landing behind a larger aircraft on crossing runways, cross above the larger aircraft flight path. If the larger aircraft is departing on the same runway, note its rotation point and land well prior to that point. Here, the larger aircraft is departing on a crossing runway. Note the rotation point. If it is past the intersection, continue your approach and land prior to the intersection. If it rotates prior to the intersection, avoid flying below the larger aircraft flight path. Abandon the approach unless you can land well before the intersection.
As a conclusion, a transport aircraft should not deviate from the standard approach slope to avoid a risk of encounter. However, for light aircraft, with low approach speed, approaching on a long runway, it is an acceptable procedure to perform a high approach and a long landing, targeting a touchdown point after that of the previous aircraft. It is to be noted that, when on an approach, there is no risk of encounter with the vortices of an aircraft taking off on the same runway, as a vortex will only move backward due to the wind effect. Such a vortex will have a very limited strength, and in the case of a strong headwind may even be dissipated completely. However, with crossing runways, depending on their geometry, and with inappropriate procedures, it may be possible that, very close to the ground, a landing aircraft enters the vortex of an aircraft which took off on another runway. Pilots on the approach need to maintain a general vigilance and awareness, especially with calm wind conditions.
Aircraft upwind from a larger aircraft is unlikely to encounter any wake turbulence. However, it is not always possible or practical to have a smaller aircraft follow a larger aircraft on the upwind side. Another consideration controllers need to make is the flight path of the preceding aircraft compared to the flight path of the following aircraft. A steep descent of larger aircraft could create a hazard for smaller aircraft following on a normal descent to the same runway. As you can see, at some time, the smaller aircraft would be below the flight path of the larger jet. When practical, air traffic controllers should advise the following aircraft of the leader's steep descent. Faster aircraft following slower aircraft can create a serious wake turbulence problem by easily getting too close. The separation distance provides time for the wake turbulence to dissipate as well as descend. Intersecting runways can also create a hazard when a small aircraft is cleared to land on a runway where the flight path will take it through the flight path of a larger aircraft that was landing or departing on a different runway.
Departure. During the takeoff phase, other than time separation, no avoidance procedure is applicable, as the maneuver is dictated by characteristic speeds v1, vr, v2, determined by the weight, the weather conditions and the runway. The time separations given for some aircraft types ensure that possible encounters after takeoff remain controllable. When no time separation is given by ICAO rules, the separation is decided by the ATC to obtain a minimum radar separation, depending on the departure trajectory, and long experience has demonstrated an acceptable level of safety. For a light aircraft taking off from a long runway behind a transport aircraft, it is recommended to choose the departure point in order to achieve a trajectory well above the preceding aircraft.
Be alert for any critical takeoff situation which could lead to a vortex encounter. In takeoff situations, note the departing aircraft's rotation point and rotate prior to it. Be sure to evaluate aircraft performance and determine if it is possible. If necessary, or there is any doubt, delay the takeoff. After takeoff, continue your climb above and upwind of the larger aircraft climb path until turning clear of its wake. Avoid any headings which will place you behind the preceding aircraft path. In the case of an intersection takeoff on the same runway or parallel runways, be alert to adjacent large aircraft, particularly upwind of your position. Avoid subsequent headings which will cause you to cross below a large aircraft path. In the case of an aircraft making a low missed approach or touch and go, wake turbulence may exist along the runway and in your flight path, especially if a light quartering wind exists. Leave an interval of at least 2 minutes before executing a takeoff after a heavy aircraft. If you are en route VFR and you observe a large aircraft above on the same track, avoid the area below and behind its path by adjusting your position laterally, preferably upwind.
Wake-vortex phenomena are dangerous during takeoff and landing phases, forcing air traffic controllers to reduce the flow of aircraft. The wake-vortex radar, LiDAR sensing technology is a way to improve detection and better assess the consequences of the phenomena, thus making air traffic management more precise. Air traffic booming by 2020 is forecasted by all stakeholders, and major airports will approach their ultimate capacity with increasing delays. Wake vortices are the principal limiting factor in regards to runway capacity. All aircraft generate wake vortices. Wake vortex strength and duration depends on aircraft type, weight, wingspan, etc., weather conditions, wind speed and direction. Air turbulence wake vortices are encountered during touchdown. Below 100 feet in altitude, severe wake vortex encounters mainly occur at less than 500 feet in altitude, while turning onto glide slope, between 3,500–4,500 feet in altitude, during takeoff. Impact on aviation safety. Wake vortex encounters are responsible for severe incidents and accidents. Capacity. Conservative separation minima imposed by ICAO to ensure safety. Aircraft heterogeneity, highly variable separation distances and decrease in airport capacity with the arrival of new heavy aircrafts. Airbus A380, a stretched version of the Boeing B747-800, and light jets.